Welcome to Hydrogen as a Fuel panel. In this panel, in this full day, we're discussing a number of fuel options for the future. Now, in this panel, we would like to discuss hydrogen as an option. Hydrogen is building momentum globally as probably the cleanest of all fuel solutions for the future. In that regard, several shipping players have recently issued a joint letter to the EU Commission urging to promote the use of green hydrogen by ships as part of its upcoming maritime fuel law. There's a Green Deal and a number of initiatives running across in the EU. Now, what we would like to discuss, as in all similar panels, what we would like to discuss today, market momentum, success stories, key challenges, drivers, barriers, CAPEX, OPEX, price considerations, and more or less competitive strengths and weaknesses of hydrogen against other fuel options in the short term and in the long term. So in order to have this discussion, we have assembled a panel of experts. Let me briefly introduce them to you. We have in this panel being joined by Madadh MacLaine. Madadh is the Secretary General of Zero Emission Ship Technology Association. We have Jogchum Bruinsma, who is the Project Manager for Maritime Power Systems at Nedstack. Pratt, who is the CEO and CTO of Golden Gate Zero Emissions Marine. And last but not least, Konstantinos Theofanis Markou, who is the General Manager of the Athens office of ClassNK. I would like to welcome you all to this panel. And I would like, as we have the first order of business out of the agenda, I would like to start with a set of presentations asking Madadh to share her screen and let us have her presentation. Madadh?
So first of all, ZESTIS, Zero Emission Ship Technology Association, we are an international trade association. We are representing primarily OEM, whose technologies of zero emissions point of use on ship with minimal upstream impacts. We're operating in over 17 countries on 3 continents, and our members have projects in, I won't go into detail here because we don't have the time, and across pretty much all of the maritime sectors. The first thing I want to say is just a very high level market momentum. If you look at this what I call an exponential trend curve, you can see that we started seeing some very small hydrogen vessels coming on the water in 1998. And in the last decade, we've seen an uptick in hydrogen vessels with that curve beginning to become exponential roundabout now. And we've projected projects that's shooting upwards towards 2030. 4 vessels that will be coming on the water this year are Zulu, or two barges, the Zulu hydrogen barge and the Future Proof Shipping hydrogen barge. Also, we'll be hearing more about this vessel, the water go round from Pratt, and also the Norled hydrogen, liquid hydrogen ferry coming on the water later this year. And it's just been recently announced. Wallis Williamson High Ship Project, a row on, row off ferry will be coming on the water in 2023 with 3 megawatts and liquid hydrogen. So speaking of momentum here in the North Sea region, locally, we're beginning to see an uptake in hydrogen bunkering projects. There's three projects active in Kirkwall, in Amsterdam, and in Lundberg, with 3 more projects under construction. 14 are actually funded, and another 8 at concept stages. So we've got momentum. This is moving forward. I think one of the biggest issues that we talk about in hydrogen is for the larger seagoing vessels. The ICCT, they're well known for study that they're well known for exposing VW. I think that's what they're best known for, but they have done a study on a route from US to China looking at container ships, and have found that all vessels on that fleet could transition to liquid hydrogen. There'd be a slight shift in operational profile. Some vessels would need to stop and bunker in the Aleutians, but this is found to actually be on their route. So with a shift in operational profile, there is all vessels, the largest vessels that are transiting from Asia to California would be able to operate on liquid hydrogen. And I've put the reference in there, so if this is shared, which I hope it will be, you'll be able to look that up for yourselves. Another thing that we talk about is that the cost of hydrogen. So I think that one of the problems is that we're looking at renewable energy and green hydrogen projects are really at pilot stages. We're talking megawatts now, and we're talking about hydrogen production. We really need to be talking about gigawatts. And when we get to 2030, we will be talking about gigawatts, and we will have achieved economies of scale and a levelized cost of hydrogen of around $2 a kilo. So that translates to 200 US per ton. Now, the energy ratio between hydrogen and low sulfur fuel oil is around 3.3. So if we take the price on the price of low sulfur fuel oil in Rotterdam on the 1st of April, in equivalent energy, that's 166.5 dollars US for low sulfur fuel oil to equal the energy of 1 ton of hydrogen. Going forward, we can be assured that there will be market-based measures. We don't know what and how much, but we can assume that they'll be around, given the conversations that are happening, they'll be around 100 and 300 dollars US. This would bring the price of low sulfur fuel oil up to around 2,000 to 2,500 equivalent energy post 2030. So you can see that we're talking, that's equalizing that price. So equal or even less for hydrogen in 2030. So the reason why the Zero Emission Ship Technology Association gets behind green hydrogen is that it's the only fuel where the energy component remains zero from well to wake. There's no nitrous oxide, which has 300 times the greenhouse gas impacts of CO2. It will be compliant with all future environmental regulations due to the lack of upstream impacts. And this is very important when we look at IMO greenhouse gas working group agenda item 5, where we'll be looking at considering the upstream impacts. So looking at the development of life cycle greenhouse gas carbon intensity guidelines for shipping. So that's green hydrogen is the only maritime fuel that is accepted as zero by zero greenhouse gas emissions by the Zero Emission Ship Technology Association. And without further ado, I turn back over to Apple. Thank you.
Okay, thank you, Madadh. Let's hear from Joe. Joe, let us, let's say, have your presentation by sharing your screen.
Thank you for having me here. I've been working in the hydrogen fuel cell space for over 20 years. From 2010 to 2018, I was at the Department of Energy, Sandia National Laboratories. And most of my time there, I was focused on the use of hydrogen for marine vessels. In 2018, I left the national lab and started Golden Gate Zero Emission Marine. You can see a picture here of our most famous project, which is the Water Go Round, recently renamed the Sea Change by the owner. So I will speak briefly on the future or the reasons why hydrogen can make sense as a marine fuel. Before I jump into that real quick, I do want to mention that we are changing our name from Golden Gate Zero Emission Marine to Zero Emission Industries. We have seen the transfer of technology from the marine space over to other applications on land and stationary power. And to reflect the broadening of our work, we're taking a little bit broader name. We're still staying true to our maritime core and focusing on a lot of the applications in marine. What are those? Where can hydrogen be used in marine? This comes from a study that we did just before I left Sandia about the limits of hydrogen applied to different vessels in the world's fleet. And the purpose of the study was to find what is the maximum size or power of a vessel that could be powered by hydrogen. And much to my surprise, we did not find a maximum. In fact, even as the vessels got larger, it was easier to retrofit them to hydrogen and fuel cells without sacrificing cargo or passenger space. So this study is available for download. You can see the link at the bottom. And as Madadh pointed out, hydrogen is the only fuel that enables zero carbon and zero pollution operation. That's not to say that it's easy today. While you can do all of these vessels with today's technology, in order to achieve true widespread adoption, there are four main issues, in my opinion, that need to be addressed. One is to increase the availability of hydrogen infrastructure or awareness that that infrastructure exists. Many people don't know that hydrogen is produced and used in massive quantities all around the globe today. The second is an established set of relevant safety codes and standards for the installation of hydrogen on board. Third is improvements in hydrogen and fuel technology, hydrogen and fuel cell technology to decrease cost. And four is education, so that people who own vessels or want to ride on vessels understand that they have the option of hydrogen. Compared to other fuel types, hydrogen and fuel cells is the only one that the cost is decreasing, not increasing as we go on. Fuel cell cost is coming down as a result of mass production of fuel cells, and part of that market is the light-duty vehicle market. Because they share the same common core components, the fuel cells used that would be used for ships will also see the benefits of that increased economies of scale. And as Madadh showed, as we get more renewable energy and the cost of renewable energy decreases, the cost of hydrogen is also decreasing. The result of these is a lower total cost of ownership for a vessel at the least. And it will soon be at the point where installing fuel cells and hydrogen is actually cheaper than conventional power. When we look at other fuel types in consideration, I want to point out two things. Number one, if we're talking about zero emission, hydrogen is the only way to do that, or you make synthetic versions of the fuels listed on this page. But every fuel here, and I showed the chemical formula for all of them, contains hydrogen. So if you're making any of these from hydrogen as a renewable fuel, you need to start by making hydrogen. So why then would you take the hydrogen and convert it another step to something else when you can use it directly and get zero emissions? The reason primarily is people are concerned about the weight and the volume of hydrogen. But as you can see on this slide, it's not a huge difference between the existing solutions, especially when you're talking about liquid hydrogen. Now, there is a difference between liquid and gas, and I'll talk about that next. This is an example vessel that is a pretty large installed power, about 38 megawatts, and it travels around 200 nautical miles on its route. We could do this vessel using fuel cells and gaseous hydrogen without modifications to the passenger handling or cargo handling capability, but you would only get one-way trip. If you go to liquid hydrogen, you can store more hydrogen on board, and you could go 5 trips and have 50% of the weight and 25% of the volume. So this shows the importance and the difference between liquid and gas. This is important because in most of the world, liquid hydrogen is not readily available. Over 85% of the liquid hydrogen production and distribution is in North America today. So in order to take advantage of the properties of liquid hydrogen, this gets back to one of the other challenges I spoke to earlier, is the establishment of liquid hydrogen infrastructure around the world. I want to conclude by just noting two of our most famous projects. One on the left is the water go round or sea change, and that will be beginning sea trials very shortly here. And the other one is the small fast boat. One of the vessel types that was most challenging to convert to hydrogen fuel cells was actually the smallest and fastest. So in our way of doing things here, we decided to tackle that next. Let's tackle the hardest challenges first. And so we have a grant-funded project to do a small, fast hydrogen fuel cell vessel that can be used as a small harbor craft, patrol vessel, things like that, and also recreational boats. If you have any questions about any of these projects or other things we're doing or about hydrogen in general, please reach out and I'll be happy to help. Thank you very much.
Thank you, Joe. Let's hear from Jogchum.
So thank you for the invitation. My name is indeed Jogchum Bruinsma. I'm application manager, project manager at Nedstack. And Nedstack has been in the fuel cell business for over 20 years. And we mainly focused on fuel cell business from an industrial point of view. So not the passenger car lightweight fuel cells, but heavy duty and stationary, but also long-running fuel cell plants. At Nedstack, we are proud to have our fuel cell excellence from powder to power. So we start with bulk molding compounds. We make our own cell plates, our own cell voltage monitoring system, and assemble them into fuel cell stacks. And those fuel cell stacks are our building components in fuel cell driven power plants. And those power plants we build with co-makers from the industry. So we build together with Maritime system integrators. We built the power plants to fit Maritime use. And for instance, for industry, we use other integrators because we want to combine the best of both worlds. We have a track record in fuel cells. So fuel cells are not new. The first power plant that we've built was already back in 2007. So it's been running over 10 years, showing that fuel cells are capable of running very long operating hours without requiring a lot of maintenance. We also built the first megawatt power plant, which was already also 10 years ago. So also large scale fuel cells are not an issue. And the largest fuel cell power plant is over 2 megawatt electrical power, which is also built by us. And all of these plants are located in seaports. So we are very acquainted with the salty air, which is not a problem in our system. So from a maritime perspective, we also made some early steps already for fuel cells on board. We had a passenger vessel approved by DNV back in 2010-11 to sail around with 80 passengers. And more recently, we also did a project with, for instance, Lloyd's Register to find out where are the challenges, what are the barriers that we need to overcome when applying fuel cells in the inland navigation, for instance. So why think about fuel cells? There's a simple answer. If we look at, for instance, this study from Lloyd's Register and UMass, if we want to bring emissions down, as we agreed in the IMO, we need to do something today. And zero emission vessels are gonna be a big part of that, because that will compensate for the vessels that we cannot go zero emission straight away. And fuel cells deliver this option. In a fuel cell, there are no other emissions than pure water, because you're not actually burning air or anything. You just have a chemical reaction between hydrogen and oxygen forming pure water. And in this process, you have electrical energy. And that electrical energy we can harvest from the fuel cell stacks and use them to propel vessels and to power, for instance, accommodation. To overcome the first hurdles, we are also working on concept designs. to find out, okay, what we have to do when applying fuel cells in a vessel. So we've worked on a tugboat, which is very small and contained, but also on a DP2 offshore vessel, for instance, which seems to be very feasible, for instance, to start now to do zero emission operations when at the wind park. And maybe for transit, you still have a hybrid diesel application, but you can start with this hydrogen fuel cells today. And one of the other things we see ports struggling with applying large power shore connections, and with mobile shore connections, you could also supply megawatts of electric power to big ships that are in port to be able to switch off their main engines. We're also working on a few projects in the Netherlands that are already there, which are also being built this year. I already mentioned the Maas, but also the Antony is an inland barge that will be sailing on hydrogen next year. And we have a large ISHI project with both offshore vessels as well as inland vessels that are also gonna use both hydrogen with fuel cells and some internal combustion engine. But it shows, I think, that the first projects, especially in inland vessels with hydrogen, is not something of the future, but it's happening today, and the first vessels will go into operation. So if you want to learn a bit more of what we do and what we can assist you with, please feel free to reach out, and I will leave it to that.
Okay, thank you very much. Now let's hear from Konstantinos in order to conclude this set of presentations.
So I will present this hydrogen fuel cells for marine use short presentation as prepared by our head of Syntop. It will consist of 4 parts. The first will be the properties of hydrogen, general properties. Second, hydrogen fuel cell in maritime section. Third is the ClassNK activities. And number 4, the rules for hydrogen fuel cell ships. So the properties of hydrogen, the pros are the zero emissions for nitrogen oxides, sulfur oxides, CO2 and particles, but also low vibration, low noise if used in a fuel cell. However, the cons are the low energy density, approximately 1/5 of the heavy fuel oil, cryogenic storage necessary in most applications, -250 degrees Celsius, difficult to handle, of course, less bunkering infrastructure, and the brittlement of metal materials. Ongoing projects are presented here, the ongoing projects on hydrogen as a fuel. Most of the projects, as you can see, and as our co-presenters also referred to before, are for passenger ships, car ferries, and tugboats. So several projects are ongoing, but due to the space limitation, we are going to list a part of it. As you can see here, and as mentioned before, many of the fuel cells are made by Ballard and Nedstack. World first hydrogen fueled ferry to be commercially in use is probably the MF Hydra. More details will be followed in the next slides. In Japan, the situation is presented also. ClassNK is engaged to pleasure boat project as led by NYK and other projects by the E5 lab. Therefore, we will explain this in the next slide. Project is led by Iwatani Corporation and KEPCO, which is the electricity company of Japan, and is aiming to develop a ferry in order to be commercially in use for the 2025 Osaka World Expo. Yanmar also is planning to conduct a demonstration operation of a pleasure boat using Toyota's fuel cell this year. The demonstration operation of the prototype has already been completed. So examples of hydrogen fuel cell vessel projects is the first example is the MF Hydra, which is built by Turkish shipyard Norse company in November 2020, and currently on outfitting a Norwegian company Weston Yards. It is equipped with a liquefied hydrogen tank of 80 cubic meters, fuel cells of 2 times 200 kilowatts, and a generator of two generators of 440 kilowatts each. Another project also presented before was the water go round. which uses fuel cells of hydrogenics, a composite tank by hexagon, pressure to 250 bars, and the hull is made of aluminum. Is equipped with 1,000 kilowatt-hours battery. Demonstration test is conducted by Sandia National Laboratory, Department of Energy in USA, and the project was scheduled to be launched in 2020, but is being slightly delayed and is scheduled to be launched in 2021. Either MF Hydra or water go-round are forecasted to be the first commercially used ferry powered by fuel cells. Manufacturers which have business experiences of fuel cells for land uses are also trying to expand in the maritime section. FC fuel cell module developed by Nedstack has been used in demonstration projects in Europe as well, as we have seen before, but also fuel cell module developed by Hydrogenics is planned to be used in US water go-round project. Toyota is also scheduled to obtain type approval for marine use around 2022 year, and Toshiba also is planning to enter the marine business in 2021 as an EDO, which is the New Energy and Industrial Technology Development Organization in Japan, target. So these Japanese companies are now under discussion for obtaining ClassNK approval. Two more projects are presented here. The first one is the E5 lab with the E5 tag projects. It uses the battery as a main power source and the hydrogen fuel cells and generator as used as an auxiliary power source. They are planned to be commercially used in the port of Yokohama by 2022. And also the second one is a sightseeing boat in Yokohama, which is a mid-size sightseeing boat with a capacity of 100 passengers and gross tonnage 150. NYK is leading the project. Toshiba is implementing the fuel cell system to ship and developing the operational technology. Kawasaki Heavy Industries is developing an onboard hydrogen fuel supply system and the EMS. ENEOS is developing a hydrogen fuel supply system. And ClassNK is conducting the safety assessment of fuel cell equipped ship. IMO's guideline are presented now. The guideline equipped with fuel cell was scheduled to be finalized at the committee, but at this committee 7, but has been postponed and has been rescheduled to September 2021. And also the Maritime Safety Committee is rescheduled for October 2021. The guideline is a compile of a general requirement of fuel cells, so it doesn't have any requirement for a certain fuel. And additional guidelines for methanol and the other ships will be applied in this case. NK guidelines for fuel cells. Currently, revision on rules for the survey and construction of steel parts of steel ships, Part H, are being developed, incorporating the information for large capacity storage batteries guidelines and updates on the guidelines for ships using fuel cell systems are scheduled and will be developed according to the progress of the projects that we are currently participating in. Thank you very much for your attention.
Thank you very much, Konstantinos. Thank you very much. Now, we'd like to have a discussion, and I would like to thank you for the presentations. You highlighted a number of practical examples. However, I'm starting from the end because especially Konstantinos highlight a number of issues. I'll start with the easy one, the legislation. I understand one of the impacts of COVID is that, let's say, has applied a pause in a number of things. No one can visit the IMO building. Visiting to the IMO building will be resumed. This is what the guys close to the IMO are saying to us early June, maybe. Now, we are behind schedule. I assume, and I would like you to confirm that more or less the regulatory framework will be in place in the years to come. I think all of this is a technical challenge, but I think we have the means as a community in shipping to make this happen. Do you see any sort of difficult challenges with regards to regulation?
Of course, we are in the process of doing this, and there are some delays which are inevitable due to the current situation all over the world. And I think that these delays also have delayed in our experiences for the setting up the framework for this legislation, which is necessary in order to proceed with the wider use of this fuel cell as a propulsion means. I think that it will be more or less, it will be in place by the end of, by mid of 2022. This is my current estimation.
If it's not 2022, I would like to say it may be 2023, but you know,
yes,
it's in the process. We cannot be certain and sure, but it's in the process.
It is in the process, and the needs have been recognized, so more or less we are in the process.
Correct. So we take this out of the equation. We have set something like a score for all the fuels. Yes, Jogchum, yes.
Maybe I can respond to the question as well, because indeed regulations are not there yet. They're in development. And when we have fuel cells, I think next is also hydrogen, because we don't have any specifics on hydrogen. But of course, we have the alternative risk-based design method, which enables us to start today and just prove that we're equivalently as safe to what is there now. And it's also part of regulations to use this method. So it's not stopping us, and it doesn't need to stop us from developing projects.
I fully agree, understand that. Yes, Madadh, yes.
Yeah, and I'd just like to add that one of our members is moving away from the alternative design route and is moving toward a goal-based approach, which is making this move again a bit faster. So in spite of the fact that we don't have the regulation in place, we are able to move forward, and this information that is gathered as these projects are developed will then feed into that regulation, assuring that it accommodates all of the innovations as they come forward, as they are developed.
Okay, I haven't seen anyone presenting on safety considerations, but I mean that could happen in the future. Now, as I said, we have something like a checklist, like a score. We have 10 key points that each fuel has to score. So there are a number of issues I would like to discuss, starting with the maturity of the technology and the maturity of the market. I've seen more or less what you presented, all of you, was inland vessels, short sea, maybe small ships can hydrogen and more or less fuel cells of that approach. Can, let's say, that sort of approach maybe applied to deep sea shipping? That's a question for us in shipping, because it's not only inland barges and small boats, etc. We're talking about big ships, big container ships, big dry bulk carriers, big oil tankers, and so on, and LNG carriers, and so on and so on. I'm not saying it's the best solution, but I would like to hear from you. How many years do you think it would take? When are we expected to see something like that? Should the technology go to that front? Madadh, your thoughts?
Yeah, thank you. I think we can see by the ICCT study on the route, one of the longest routes in shipping from Asia to California, that it is possible for container vessels, and also the work that's been done by Sandia National Laboratories, showing that no matter the largest size vessels, that we would have room for both the fuel and the propulsion system. For me, the biggest thing that's holding this up is the fuel itself, and it's just a matter of building out that infrastructure. We have the technology. We just need to scale it up and get it out there.
My question was also about the possible time frame. What can you share with us?
Right, time frame. I think 2030 will be up and running. We will have achieved economies of scale, and we will have that infrastructure in place if it's supported. If the build out is supported.
I have a comparison with LNG, which LNG seems to be the most promising. If we leave VLFSO and move towards decarbonization, LNG is the first step, and we always tend to compare everything with LNG. And I have to, as we continue our discussion, just to put some fuel into the fire, to put it in that sense, and provoke you. The experience-based building with the LNG, I mean, here you don't need the engine, but in order to have the engines and test everything and have the infrastructure, it took us maybe 10 years, something of that range. And even now, today as we speak, we're talking about, if we exclude the LNG carriers, we're talking about 400 ships. I mean, in operation, plus, on the building phase. It's a small number of ships, and we have too many years having this discussion and the experience transfer. We also have to accommodate for that. I understand Jogchum and I'm not sure, but Konstantinos demonstrated a number of practical examples, and I fully respect that. But we have to bear in mind that it will take maybe some time for the experience building phase. 2030 is an issue. Joe, your thoughts?
Yeah, I think it's interesting to compare LNG to hydrogen because there are similar fuels when you talk about cryogenic low flashpoint fuels, but there is a key difference that I think will affect the build out of infrastructure. And that is that nobody's looking at making their own LNG for energy independence reasons. And that's why many governments around the world are thinking about hydrogen. It's not simply as a marine fuel. It's for an entire ecosystem that's being built out in areas where they don't want to be importing fossil fuels anymore, or maybe they have it, but they don't want to be using it. Now you can use hydrogen to create fuel from solar, wind, or whatever natural resource you have. And that affects the rollout of hydrogen production. And then, as Madadh pointed out, that is a key reason why you will have hydrogen for marine at the large scale, and then can support these transoceanic ships. So if I was to predict a timeline here, I would look more at what national governments are doing, or ports around the world, in terms of just developing the liquid hydrogen production capability to support their own internal interests. And that is going to be the indicator of when you're going to have enough hydrogen infrastructure in order to support the deep sea shipping.
Yeah. Jogchum, any comments on that?
Yeah, I think things are moving very fast, and of course things need time. But when I started Nedstack 3 years ago, nobody was really talking about hydrogen in the business. And now we're 2.5 years later, and we have the first vessels really going on hydrogen on a commercial basis. Of course, they are pilots, they are the pioneers, but they will show that this technology is possible. And for seagoing, we need a massive amount of hydrogen, for sure. And we need to build those plants. And building those plants from plan approval up to construction, that will take another 5 to 7 years for sure. But by 2030, we could be at this stage that we can have also the seagoing vessels going on hydrogen. And we've done then inland vessels maybe earlier. We've learned from that experience. And I think with LNG, it was primarily pushed, I think, also by the commercial end and about the sulfur. And now you see this hydrogen movement behind it, and the climate changes, and hydrogen also being the fuel, for instance, for industry. So I think there is a larger momentum than there was when we started with LNG.
Yeah, maybe. Konstantinos, your thoughts?
My thought is that, as we all know, shipping is a very conservative industry because of the large amounts of capital is necessary to be invested on any new technology. So I think this is the main driving force behind this. Of course, infrastructure to be in place is the first thing, but I think that there should be a push also for the better of all the human of the earth. Is if there was a legislation or this taxation on CO2 emitted, that would help. But the ship owners would be very reluctant to see and to meet.
I know. Yeah.
So this is my point of view about this.
Yeah. I think there's an elephant in the room, especially when we're talking about decarbonization in shipping. And the elephant in the room is exactly what Konstantinos said. The cost of moving to this, new or maybe carbon-free, to put it in that sense, shipping. Now, the actual numbers, the real numbers, the estimated value of the global fleet is in the range of 1,100,000 ships, cost approximately $1 trillion US. Now, the cost of decarbonization may be something in the range of 2 to 4 trillion US dollars in the next maybe 10 to 20 years. The problem is, if we, and that's a real problem, and all of us have to bear in mind, I hear people making calculations in the range of $100 tax, carbon tax. Now, in shipping, we use approximately 350,000 tons of diesel per annum, giving us approximately, and it's easy for our calculations, 1 billion tons of CO2. Now, if someone says, let's tax them with $100 per ton, that would be 100 billions per annum. Now, only the cost of the tax, not the cost of the fuel. Imagine. Now, my next question, which is an actual, burning question, what's the cost of the fuel? Because I've seen in Madadh's presentation some figures, and I'm ready to jump, say from my seat, from where I stand. So what's the cost of the fuel? What's the cost of hydrogen, and what's the cost of the green hydrogen? Because now we have a figure for the cost, and exactly what Konstantinos said. Shipping is a very conservative industry, and when we start talking about these figures, whatever the figure it is, we have to multiply by 350,000 tons per annum. So that's a huge cost. Madadh, can you start sharing with us what's the equivalent cost in terms of equivalent cost of energy for hydrogen and green hydrogen? Because I think I noted something in the range of $1,666, something like that in your presentation. You are muted.
Sorry about that. Yeah. So in my presentation, so there's roughly 3 times the energy in a kilo of hydrogen than there is in a kilo of fossil fuel. So the equivalent, if the price in Rotterdam when I did my presentation was 500 US a ton. So the equivalent energy would be $1,666 a ton for the same amount of energy as a ton of hydrogen. So we're looking at, various studies. We've come up with an average levelized cost of green hydrogen in 2030 at being around $2,000 a ton. So you're looking at, so without any market-based measures, you're looking at a spread on that particular day, a spread of around $350. So if we add in the market-based measures, we're looking at at $100 a ton. Market-based measures, you'd have about the cost would be about 2,000. Given that price, the price on that day would be. Oh, I've run out of time. It's a lot of $2,000 a ton, or $250 or $2,500 a ton. So the point I was making here is that that if we bring in market-based measures, that will levelize. Now, these will need to be approved in the IMO. So we'll have the shipping industry in the room, and nobody ever approves a tax for themselves. But I think this is one tax that shipping's not going to be able to avoid.
Yeah, during your presentation, I think you had a slide indicating that the cost of the fuel, the hydrogen, will be more or less minimized to 50% of the current prices. I think you had something in the dollars per kilojoule, I think from 10 to 5, something like that. Can you give us your thoughts on how this fuel cost may be in the near future, let's say 10, 20 years?
Right.
Yeah.
So what I'm talking. Oh, were you asking me or Joe? Sorry.
I'm asking Joe because he had a presentation on this and he had the slide over there. What's your take on this? How are we expecting to see the cost of hydrogen moving in the future?
Well, as I mentioned, hydrogen has to come from somewhere. And so it all depends on the cost of the energy going into it. And today we produce hydrogen from natural gas, which is pretty stable. So that's why we're seeing the prices that we get today, maybe about $2 at the production site, $2 per kilogram US. But the biggest cost is in the distribution and the fueling infrastructure. So it's really difficult to extrapolate the cost from small projects today to what would be required for a large ship that might be bunkering 20 or 30 tons at a time, or more, 100 tons. There's just no way to be able to predict that based on the $5 or $10 a kilogram or whatever it is you're seeing today to fill a ship with 200 kilograms. But the point is that it's going to track the cost of the energy feedstock. And as we transition to green hydrogen and we get more solar and wind, and that becomes cheaper, then the hydrogen cost will follow, even at very large scales. So I can't predict what that cost is going to be in 20 years. But all I know is that it's all going lower than whatever it is that we're getting today.
Yeah, yeah. One friend of mine, we had a discussion, and a colleague suggested something I hadn't realized. As we discuss and the progress of technology, not only in shipping in general. Let's take the iPhone, for example. The iPhone now is much cheaper. It's better, faster, cheaper than what we had 20 years ago. Yes, I know it costs maybe 1,000, 1,500, but if you add, and you have to add what you have in an iPhone, what you have in the latest model of Samsung, and so on and so forth, it would take thousands of dollars to have such an equipment, let's say, and you couldn't have it in one device. Meaning, technology moves forward to provide better, faster, cheaper. Why? And that's for all of us, not only in shipping, but for all of us, why we should go towards decarbonization at a much more expensive, let's say, solution. So that's food for thought for all of us, because I understand what Joe says, and then I've heard it in other panels as well, as we discussed today. As production will go up, prices absolutely will go down. But the key problem, one of the key problems we had with LNG, that's why I said about the experience transfer, was the let's say inadequate provision of, let's say, certain pricing in the market. And we've seen oil majors coming forward, providing certain schemes to secure the price for the players to come forward and say, yes, we will move to LNG. Otherwise, it is very uncertain. And remember that when we all of us have to remember that if you have a ship now is built for 20 to 22 years. That's the average life cycle of a ship. It's not for 10 years. Maybe in the future, we will have ships for 10 years. I don't know. But now it's a decision taken for, let's say, 20 years. So within that lifespan, we have to accommodate for that, because at the end of the day, someone has to, move forward and make the decision to invest in this technology. Jogchum, yes, what's your take? Yes.
Well, I think we are comparing apples and pears, and maybe even apples and oranges. They're worlds apart. And it's the same, if I can borrow your example from the iPhone. Yes, we have an iPhone which costs around $1,000. But I can also buy a phone of less than $100, which can do exactly the same. I can call with it, I can message with it, I can make photos with it. So you could say I have the same functionality, but at a different quality level.
Fraction, not the same, a fraction of the functionality.
But basically the functionality that phone gives you is basically the same as your expensive iPhone. Only the quality of that iPhone is better. The camera is better, but it still makes a photo. And I think the value of, say, added value of maybe hydrogen and also fuel cells, there's no price on it. There's no price yet on the comfort that you have a silent system. There's no price on the fact that you don't have any emissions at all. But there is a price on green electricity, while there is no, for instance, tax on marine diesel oil. So it's really hard to make that comparison. And we need people also to buy the iPhones and say, this is what I want, because I value the additional expenses. And this is, and then the rest of the market will follow.
I have to provoke you, because otherwise you will sell to the audience that the only solution is hydrogen. So someone has to provoke you. Konstantinos, your take?
Well, it's still very difficult to decide, because it's a very, as you said, it's 20 years before, and it's not our money, it's the money of the people who invest. And as we said before, I think it's too early to tell. I am in favor of this hydrogen solution, and I see, but I have seen it not yet implemented in less capital intensive industries, let's say, in more smaller applications, even in cars, which again is of course not yet so implemented. There are some trials, but still not widely used. So I think it will take more than we expect. I think no more or less 10 years later, mid-2030s, my opinion.
Maybe, yeah, I understand that. I mean, we have to be realistic, but again, we have to be optimistic because we have to bear in mind that technology, the pace of the technology is getting better and better as we move towards the future. Meaning, I'll just give you an example again with the LNG. A couple of years ago, LNG was, just a discussion. Now, 2 years later, it's part of the real life agenda. We've seen oil majors moving forward saying, I will commit to this and this and this. And technology moves extremely fast. 10 years ago, maybe electric cars was not a mainstream issue. Now it is. It's not only of Tesla, it's a matter of technology that progresses. Yes, Konstantinos, yes.
Yes, but there we have these Euro regulations by Europe forcing you to abandon the internal combustion engine. So again, it is about taxation and legislation.
And as you said, incentivization, absolutely, yes. Jogchum, yes.
Yeah, and I think that the difficult part is like we had with LNG, it's for hydrogen the same, and it's also why I don't know hydrogen cars is because we're not changing just the fuel, we also need to change the infrastructure. So there are no cars because there are no gas stations, and there are no gas stations because there are no cars. And I think this chicken egg problem, it needs a bit of time to break through and some early on investors that could really go into that technology. And I think for hydrogen, we're at the verge of this change. The gas stations are coming, the cars will follow. And the same yields for ships. The first ships are there with all the challenges of hydrogen supply, but they will be sailing. So then there is a demand. And that will also help others to jump in.
Yeah. Now, yes, Madadh, yes.
Yeah, I just want to following on what Jogchum has said. I mean, I work in hydrogen supply, and we're seeing that Maritime is actually cracking that chicken and egg for the terrestrial sector, that it's bringing in large enough off-takers that we can start looking at gigawatts instead of megawatts in terms of, so rapidly reducing the economies of scale.
Yeah. I would like to ask now about any possible indication on the CAPEX required to move into such a solution. Can anyone give us any sort of numbers? Maybe Jogchum, maybe Joe, I'm not sure. I'm certain that Konstantinos cannot provide any sort of feedback on the CAPEX. Absolutely. Jogchum, let's start with you. Any sort of indication on the CAPEX to move to a solution like that?
Yeah, sure. I think what you have to see, there's two things. You have the passenger car fuel cells, which is a high volume market, low power, very high volume, and not that heavy duty use. And you see those prices are projected to go very, very deep. If you look at the more maritime, and I think the stationary applications and the durable heavy duty applications, we see currently about 2,500 to 2,000 euros per kilowatt for a fuel cell system. And we expect that to certainly halve, if not further go down over time. But with that going down, also your maintenance reduces. So in the end, it might even not be a problem that they will be more expensive than the diesel engines, because you don't have that big maintenance in your OPEX anymore. So the TCO will certainly be interesting. And in some cases, it is already. But of course, we need some vessels in the water to prove that.
Yeah. Have you done any sort of, have you been asked, to provide any sort of feasibility study with this comparison between different designs to provide some more, let's say, insight on this? No?
No, not specifically. We are working in a project on more stationary to make cheaper fuel cells that will already have a target of, I think, 1,500 euros a kilogram within the next 2 to 3 years. And probably with, currently it's quite labor intensive. And with all the companies going into fully automated fuel cell production, and you talk about gigawatts a year scale, not the megawatts, then certainly prices will drop drastically.
Yeah, okay. Joe, any thoughts on the CAPEX? Can you share with us anything?
Well, yeah, first of all, I think putting it in perspective is helpful when we're talking about shipping CAPEX. Well, I should put it the other way. OPEX in fuel is around 90% of the TCO. For smaller vessels, ferries and things, maybe it's 80%, but it's different use case than a light duty, where the most important cost component here is the fuel. It's not the upfront capital. Now, of course, people want to reduce that capital cost, and I believe strongly that the fuel cell costs are coming down. I forget, I think it was Konstantinos pointed out, Toyota is working on class systems. I believe that these automotive style fuel cells that are very low cost and low weight are going to be adapted to large scale shipping eventually. And I think we're going to see fuel cell costs being less than that of combustion engines.
Most probably, to be honest, most probably this is where we're going. Now, we have to wrap up the panel. I understand hydrogen, I said it at the beginning, maybe is the most promising, maybe it's certainly part of the mix of the end game solution for shipping. Maybe what I understand, we have this discussion because we do believe that hydrogen is part of the end game solution. The same way that LNG, we are certain now that LNG is the next step towards decarbonization. It's not the end game, but again, hydrogen is one of the most promising solutions. However, from our discussion and from what we understand, there are a lot of things to be addressed as we move forward. Yes, there are good intentions, but as we say, the road to hell is always full of good intentions. Bear in mind, for all of us, I mean, that's food for thought. I would like you to wrap up your thoughts within, let's say, 30 seconds and give us your feedback as something sort of the wish list. What would you like to see across the industry? Maybe technology improvements, it's your take. What would you like to see to move this hydrogen as a fuel agenda in the near future? Madadh.
Madadh, you're on mute.
You're muted.
So no time to gather my thoughts. So I mean, the first thing that I think is the wish list is that we need a full systems approach, because if we're bringing in renewable green hydrogen, we need to be thinking from the renewable energy source. And as Joe pointed out, this is a huge investment opportunity, and also an opportunity for some of the least developed countries to get into the fuel game by producing their own fuel and even exporting it. So looking at it on a full systems approach, also market-based measures. I think that market-based measures are essential to moving this forward.
Okay, Joe?
Yeah, I guess my wish list here is for people and entities to continue moving forward with projects and demonstrating and moving the regulations forward, because it's the doing, it's not the talking or the meetings that are going to be moving this forward. It's getting the technology on the water and building out the small scale infrastructure and fueling and fuel cells, and then that snowballs into larger and larger scale. So keep doing it, keep investing in the projects.
Actions do speak louder than words. Absolutely. Jogchum.
First of all, I fully agree with Joe. Stop talking, we should be doing, because then we learn and we can advance. And in addition, I think it's very important to look at what is possible. It's very easy to say, okay, we cannot do this ship, so we won't invest anymore. But looking at, okay, what are the feasible projects and where can we use hydrogen to make those steps? And I think that is very important for the hydrogen economy coming up.
Okay, thank you. And Konstantinos?
I would like to think also, and like Joe and like Jogchum said, that I wish that this first project was very successful, and they give the incentive to move forward and to implement this solution to larger and larger ships, so that it will take over finally and be used in most applications of shipping.
Yeah,
I hope.
I'm sure we're going to hear more with respect to hydrogen in the near future. And I'm sure that we will see the technology accelerating towards, as we move towards 2025, 2030, and so on. I would like to thank you all very much for taking the time to join us in this panel and this discussion. It was informative, and I trust it was also educational for all our viewers. I would like to thank you very much. I would like to thank all our viewers, and looking forward to seeing you in one of our future events. Thank you very much.
Thank you.